Thank you very much and welcome everybody for being here. It's the last slot of the day, so I can totally understand whether you are tired and so, but because of this, I tailored this presentation, trying to make it quite engaging and so not very heavy. We will have a lot of demos, and one of the goals I have as a takeaway for this presentation is to give some ideas or to spark and challenge your creativity to see what is nowadays possible with web applications. Because maybe not everybody is aware, but native apps actually for a long time have been really the cool kid on the block. But with the time, modern web technologies could really narrow the feature gap. And nowadays, we will see, web applications offer a wide range of features, and they are extremely similar or very close to native apps. We can install a web application, we can use it even without an internet connectivity, we can provide very fast responses, and also the look and feel is extremely similar, if not the same, as native apps. So let's start. Before going on, just a couple of words about me. My name is Francesco Leardini, and I work as a consultant for Accenture in Zurich, in Switzerland. However, from my perfect Oxford accent, maybe you already noticed that I'm from Italy. And I focus mainly on web, architecture, and performance. So let's start when it was the starting point for native apps. Indeed, we can identify as a date the dawn of native apps, the 2008 June, when Steve Jobs announced the App Store. Then this was a real game changer because we have, for the first time, a centralized platform where the user can benefit and access directly and download native apps, and also developers simply upload there. At the beginning, around roughly 500 applications were available, 100 for free, and the other on the payment. But this was, since the first weekend, a real big hit, a really big success. And we can say that from that moment on, started the so-called mobile revolution, because every company wanted to have a native app, because the mobile devices, so phones, starts to be the centralized device where we can use it for entertainment or also for productivity. They can offer a very rich UI interface where people are already used to, because it is very similar, if not the same, to the OS. Of course, native apps are much more tightly bound to the OS and the hardware, and these hardware specs with the time increased. And nowadays we have phones that are really extremely powerful and capable. They are easy to find, this we already say thanks to the stores, and they are easy to open. Just with one click we can have our application up and running. That's why, together with also the innovation of a touch screen and so on, if you try to think about being in 2008, it's clear what makes native apps so successful, especially because if we compare native apps back in the time with the experience or the mobile experience of web application in 2008, well, there is quite a big gap, because web mobile navigation at that time was a far cry from what is possible nowadays. Not only the layouts were extremely dense and text-rich, but also responsiveness was very poor. It was not really something that the developers had in mind. Plus, there were a lot of other things missing. So it's clear that there was a big gap, and therefore everybody wanted to jump on this new native apps wagon and trend. However, from that moment on, the web evolved, and they started to have more the focus also for mobile devices. Therefore, we start seeing mobile-first approach. Therefore, all the websites must be responsive and easily adapted, and having a good layout also for mobile devices with a small viewport. Thanks to projects like Fugu from Google, there were the possibility to integrate web APIs and provide functionalities that were before a peculiarity only of native apps. Later in the demos, we will see how we can offer really cool and advanced functionalities thanks to web APIs. Then, progressive web apps allowed to greatly improve the performance and also allow to have offline capabilities. So our application is able to work even without a reliable and steady internet connectivity. And then, of course, we have many other features that improved and increased the capabilities and the feature set of web applications. In this session, we will focus mainly on the web APIs and progressive web apps, because I think that these two aspects are the most responsible of the greatness of the web, and they really pushed hard in order to narrow, as we say, the feature gap with native apps. I don't know how many of you already know or worked with progressive web apps. I would say one third. Okay, good. Then I will give also a little bit of introduction. We can say very simply that a progressive web app is a normal website or web application, but thanks to modern technologies that we will see in detail later, it's able to give and provide a look and feel and a very rich user experience, exactly as it would be a native app. In fact, here is the same application. One is the Android native app installed on my phone, and the other one is the light version, so PWA. Once installed, the PWA looks exactly the same as a native app. If we open it, also the layout is very similar. Now I give you a couple of seconds, try to guess which one is the native app and which one is the PWA. And indeed is very difficult or almost impossible. That's really one of the goals of progressive web apps, to provide indeed the same advanced look and feel. Now, this is the disk space used on my device. And maybe this gives you a little bit of a hint at which one is the native app and which one not. Because differently from native apps, a progressive web app does not need to download third-party libraries and a lot of other constellation of dependencies. This is indeed one of the specific benefits of a progressive web app compared to a native app. It's also easier to maintain because we have only one version live. We go live and that's it. While with a native app, we have at least two versions that for a short amount of time at least, we have to keep and maintain at the same time. Usually, it has always lower development cost because we don't need a dedicated a dedicated team or even two to implement PWA. While for native apps, we have an iOS team and Android team. For progressive web app, we can reuse entirely our web team because there are no need really special know-how for that. Therefore, this also leads to lower development costs. It's memory footprint, we already said. Also, we don't have, when we go live, we don't have to wait to the store approval. Every time we go live with a native app, the Play or App Store has to check a set of requirements and then, okay, approve. Usually, if all goes well, it takes 5 days, 1 week. But it could be that some requirements are not fulfilled, and then our native app is rejected, and we have to update the release notes, for example. This means also that, thanks to this, we are faster live to market, because we don't have to wait these constraints. We deploy to our server, and we are live since that moment. So these are some of the benefits that are really specific to progressive web apps. Let's now start looking a little bit more to the technical details. What make progressive web apps special, and also the two core components that are needed to indeed make a progressive web app installable and look like a native app. The first is the web manifest. This allows to tell the browser how should look like and how should be displayed our progressive web app. Web manifest is a JSON file that we reference in the index HTML file, and there's a set of properties. Here we see only a subset of them. These are the mandatory fields or properties we have to implement in order to display the so-called add to home screen, so allow the user to install the application. We can define a name that will be displayed under the icon once it's installed. We can define a display property. This display takes different values. Browser, that is the default, it would be the normal default experience that we have when with a mobile device we access any website. Not very exciting. But if we use the standalone value, we can see that some of the UI elements of in the browser are taken away. For example, we don't have anymore the address bar. We can even use a full screen value, and in that case, our PWA will take the whole viewport space on the device. And this is usually the choice for web games or media-rich applications. We can define the starting page of our PWA. This is again to provide the idea of having to or working with a native app. We don't want that the user accesses or opens the last visited page when he was using our application, but always the same one. Could be maybe the home page or the dashboard. And then, of course, we can set different icons that will be used to be installed on the device. If all these properties that are the mandatory, but there are optional many others, if these mandatory properties are correctly defined, we have a service worker up and running that we will describe shortly, and we access the application through a secure protocol, then the add to home screen banner will be displayed. This is a sort of a banner provided by the browser, and if the user clicks on it, it will install, and so we will see the icon that we defined on the home screen of the device. Let's see now the other core part of the specialty of progressive web apps. What can really boost the performance and also introduce offline capabilities. This is possible thanks to the service workers. Service workers are similar to web workers because both they run on a separate thread of than our web application. That means that even if our web application is closed, in the background the service worker will keep running. That's also the reason why we keep receiving push notifications even though the application is closed. Differently from web workers, though, service workers have the specific task of being a proxy between our application and the server. They are capable to intercept all the requests that are coming out from our application. And according to how we implement caching strategies, we can eventually provide responses straight from the local cache. That means that even if the user does not have an internet connectivity, still we can provide either static assets or a response that eventually match the request, because we already have cached that asset that has been requested. This also translates in very fast responses, because we don't have to go over the network. We have the requested asset straight there in the local cache. But we will see a couple of demos about that. One of the caching strategies that we can implement, one of probably the most famous, is the stale while revalidate strategy. There are plenty, but this is one of the most interesting. We implement these strategies on the service worker. So we have seen the service worker acts as a proxy, meaning that it listens to fetch events. So when the client requests a specific image or a specific URL for a service, we can define our caching strategy to listen for these specific assets. And then the service worker uses the cache API. Cache API is a web API that is used to check if the requested asset is in the cache and see whether there is a match with the requested asset. So in this case, the client requests a specific URL or a static asset. And then the service worker checks, thanks to the cache API in the cache, local cache, if there is, and if so, it returns it immediately from the local cache. But thanks to these caching strategies, the service worker will also go over the network and try to see whether there is a newer version of the requested resource. And in that case, also updates, thanks to, again, to the cache put method, updates the local cached version. This has the benefit that the following requests will benefit from a newer version locally cached of the requested asset. So we can have a very nice combination of providing very fast responses because they are straight given by the local cache, but also we go and update them from the network. It's a good combination. So far, we listed many benefits of progressive web app. However, indeed, there are also some limitations. First of all, the cache API we have seen that is used to see whether some assets are present or not in the cache allows to cache only GET requests. That means that if we request through a GET call something, then we can cache that. The next one can be, the response can come straight from the cache. However, we cannot do post and put verbs. This is because the cache API does not allow them. This is, of course, a limitation that we can, thanks to another API that we will see in the next demo, we can overcome. So it's a kind of a partial limitation. Another limitation, and this is a matter of fact, is the browser. Because native apps, we have seen, they are tightly bound with the OS, and therefore they can benefit from a much larger computation or power because they can use the CPU and the hardware much better than PWAs. Because PWAs run within or behind a browser, therefore are less powerful than native apps. Last but not least, iOS. Because Apple in the years always tried to put some kind of obstacles to the development of progressive web apps. Recently, though, with the version 16.4, web push notifications have been announced and enabled also on Apple device. So all iOS users could also benefit from web push notifications, things that was not possible so far. So this is in quotes because indeed there is a limitation, but not de facto. All right. This was the whole theory. So from now on, start the very fun part, demos, and we will have a little bit more engagement. Let's imagine the case of a long form on our website. The user starts filling this humongous long form, click on submit, but maybe the user is traveling, is commuting. There is no internet connectivity, and the user gets simply a blank page or a dinosaur offline page. Not a very nice user experience. And as we said, cache API, so service worker, cannot cache post or put actions, only get. However, we can overcome this limitation if we combine the power or the capabilities of a service worker with a web API. In this case, background sync API is a web API that allows to defer specific actions to the service worker when the user goes from an offline to online state. And this is exactly a great case to use that. Because when the user fills this form, he or she goes offline, click on submit, but instead of showing an offline page, we can inform, thanks to this API and the service worker, we can inform the service worker that there is something the service worker must do when the user maybe arrives to the city, or in any case out of the tunnel if he's driving, and has an internet connectivity again. And this is done automatically. We will see now a demo. This is of course, much shorter query. There's a bit of echo. So, and I say online. On the right side, here, there is a listening on port 3600. It's just a local BAN server. Could have been done with Node or Dino, doesn't matter. I'm online. I submit the form. And of course, we can see that the payload reached the server because we are online. All good. Now, in the network tab, I will switch to offline. I just change here for sake of the demo, and I submit. Of course, nothing reaches the server because we are offline. Now, if in the Applications tab, I go over the IndexedDB, we can see that here I have indeed the payload offline, Francesco edited, exactly what I entered. Now, if I go back in the network tab and I switch on, or I took off offline, we can see that immediately, as soon as the service worker detects that we are online, there is a sync event that is triggered, and the service worker knows that there is something to do. In this case, the service worker will read the payload from the IndexedDB and ship it to the server. And as we could see, this has been done automatically from the service worker. The user does not have to do anything. No poll, no page refresh, nothing. How can we do that? First, on the application side, we do the post. So the user clicks on the submit button, we collect all the form fields, and then we try to send it to the server. If we are online, of course, the data is shipped, and then everything is good. However, if we are offline, then we can intercept and interpret a specific error. And in that case, we go and we take the payload, that would be in this case all the form fields, and we save it in the local IndexedDB. And then we invoke a local register for sync method. So we store all the data locally in IndexedDB, and then we call this method. This method uses the sync property of the registration manager that allows to register a so-called sync tag. The sync tag name must be unique. In this case, we want to use sync for data as a unique identifier. This will be then used by the service worker to understand or to detect that there is a sync object with this identifier and something must be done. So now we are on the application side. On the service worker file, as we said, we listen to sync events. That's because the background sync API emits these sync events every time the user goes from offline to online. So in this case, the sync event is triggered. The service worker can check if the event tag property matches the identifier that we found before, and if so, we know that we have to execute a specific logic. In this case, what we want to do is that going over the IndexedDB, the local IndexedDB, take out all the payload that we saved before, so all the form fields that we saved before, and then we go and we do a post, because now we are online after the sync event has been triggered. So as we can see, in a relatively simple way, we can implement this very nice functionality in order to overcome the cache API limitation. And thanks to the service worker, we can also cache these edit actions. We can also use a NoSQL database, in this case Cloud Firestore, that is a NoSQL database that is a part of the umbrella of tools and services of Cloud Firebase. This NoSQL database allows to implement or achieve offline persistence. This means that once we set it up, once we instantiate the library, we can then collect and save in the IndexedDB all the read documents. And this is done transparently for us. We don't have to do absolutely anything. What we can do with this? So if we can use this NoSQL database with offline persistence and the power of progressive web apps, then we can achieve and implement a really true seamless experience. That means that a web application that the user can navigate and use, and either offline or online, it will simply work good in the same way. So I switch to the other demo, and now I also mirror my phone. So We have on the left side, so both are the same Progress Web App. On the right side, we have the one client that is using, in this case, the desktop version, and on the right side is my phone. Exactly the same PWA that uses the NoSQL database for showing these documents. I can open one document. I change the title, for example. This application is a project of mine where we register a nice restaurant. So if I visit again the place, I can then suggest to friends or so. But the cool thing is that I edited this document on my phone. As if you can see, the same entry on the other side, so on the other client, got updated as well. That's because the NoSQL database, once it receives an update, propagates, thanks to the sockets, WebSockets, propagates this update to all other clients that don't have to poll or refresh the page. They simply get it automatically. But now comes the cool thing. I go in airplane mode. So let's imagine we are traveling, hiking in the Alps or whatever. And here there was the title with offline, and I take it out. Then let's take even a new one. Let's say this is good. And then save this as well. So we can see that the changes that I did, of course, are reflected only on my phone because I'm offline. I'm traveling, I'm sailing, or whatever, and I'm not connected to internet, of course. But now, Cloud Firestore detected or saved those changes locally on an IndexedDB that is created out of the box for us. And then, thanks to Progressive Web App that allowed to cache locally all static assets, so the images, the layout, and so on, even if I'm offline and I refresh the page, I can still read them. Thanks to the Cloud Firestore Offline Persistence, we can edit them, and I'm totally offline. As we can see, I could still work and edit those documents. Now, the other cool thing is that if I switch off the airplane mode, and as soon as I will go online, Cloud Firestore will detect that there are a set of pending changes locally. And automatically, or I would say automagically, I would expect that on the right side also it will be updated. And this is totally transparent for the user. The user doesn't know that even he or she is offline. So let's say I go out of the tunnel, I don't touch the phone, and voila. We can see that within few seconds, Cloud Firestore grabs the pending changes, updates with the server, and the server propagates to all other clients. So we could, with these technologies and the power of Progressive Web App and Service Worker, we can really implement a feature or an application that no matter online or offline, simply work. And the user does not have any clue being offline or online. And this is a very nice experience. And this leads to the second part and the second topic of our presentation. So web APIs allow us developers to really bring new and innovative functionalities to our web applications. Web APIs are framework agnostic. That means that we can use it with vanilla JavaScript, React, Vue.js, or Angular. Doesn't matter. They all work the same. The first one we will see is the ambient light interface. Ambient light interface is a part of the Sensors API umbrella of APIs that allow to use and interact straight with the hardware sensor of the device. In the specific case, allow us to read the amount of light around the device where the application is running. And with this, we can then do whatever we want. Let's imagine, or let's think about Google Maps. We open Google Maps, and I don't know whether it ever happened to you. You are driving, maybe you cross a tunnel, and then automatically you can see that the application turns into a night mode in order to provide a little bit better color and make easier to read it. We can do, thanks to this API, we can achieve exactly the same in our web applications, and this is really cool. Think about you are implementing a web application, or you have a website where you provide blog posts. Of course, we can, with a toggle or an icon, we can switch to light and dark mode. However, the user maybe doesn't know that, or it opens the application at night in bed, maybe there is not much light and it was still light mode and it will get flashed by the light mode. We can implement this in a very few lines of code. We can implement this smart functionality and automatically switch to light and dark theme for our application. Let's see. By the way, also the Devox schedule application is a PWA. In order to check this, you can, in DevTools, in the application tab, you can see there is a service worker and the manifest sections. And these exactly explain and describes the details, the state also if the service worker is up and running and so on, as we defined in our file. Plus here down, you can see, if you click on here, you can see all the other application or website that have been, that you visited and then registered a service worker, maybe without you knowing that. All right, so this is the demo that we are going to use. There are plenty of web APIs. At the end of the session, you will get the repo, the GitHub repo, so you can not only play with it, but also see all the code. Of course, I have to use for this demo this is I wanted to show. You can see we said before in the web manifest display standalone. Standalone means that we can see here I have Chrome, but on a separate standalone tab, I have my PWA that indeed look like a native app. I have WhatsApp, that is Android native app. I have my PWA. However, this is open as a separate window than Chrome, even though it's a web application. But again, to provide this idea of native app feeling. So, if I go closer to a source of light, to the lamp, we can see that the light level, I don't know if it's visible, but increases. So 600, 900, and so on. And we are in the light theme. However, if I go on a darker part, or I cover the sensor, I go below a specific threshold, and you can see automatically the website is smart, or my web app is smart enough to switch on the dark theme and so. Another interesting thing, did you see that for a second my screen went on dim, went on standby? There is also another, but we don't have time to show that, another API, you can have a look at that later at home, that's called Screen Wake Lock API. With the user gesture, you can say, okay, to the screen, don't go in standby. Let's have a hardcore, very quick demo. So if I now, with the user gesture, I say, I wanted the screen to remain on, I will leave it there. We go on with the next topics. And when we come back to this screen, we will see that my phone is still on, up and running. And this API could be extremely beneficial for applications where we, for example, music application. The user play an instrument and both hands are busy. Therefore, even if the phone is set to stay 1 or 2 minutes on, might be not enough. Or if you are like me, I'm Italian, I really like cooking and so on, and so you are making a cake or something. It's not really practical when you have hands full of dough and so on, having to unlock the screen. And these API indeed have been used extensively in websites that provide recipes, and the engagement really increased a lot. Because in a very simple way, you can keep, you see how much I talk and it's still on? You can keep the screen on, and in specific scenarios, this could be a big benefit for our users. But, yeah, another... I lost this one. No. Oh, great. I lost the presentation. Cool. Right. So this was the ambient light. How we can implement it? Again, is super simple. And this is another benefit of this web API, because the result is really cool, very nice. We can really implement innovative application, innovative features, if you think about the normal default context of web apps, and it's very easy. So we create an instance of from the ambient light sensor interface, and then we have an instance of the sensor, light sensor of the device. Invoking then the start method, we can really start reading the amount of light that the sensor detects. This is given as a number, it is an integer, is the amount of so-called illuminance as a unit for the amount of light. And then we can listen the variation of this amount of light and define the logic we want. In the demo we just saw, we set the threshold of 50, so that the 50 or lower, we can say, okay, the user is in a dark environment, please switch to the dark theme. Otherwise, bright theme. But again, 20 lines of code, and we have this functionality. Very nice. Another nice API that is a part also of the sensor API is the device orientation. We can listen to different events that tells what is the physical inclination of our phone over 3 different axes. So alpha means left to right, beta back to front, and gamma tilting. And then, knowing this, I took inspiration from the native app Revolut, where you can flip back and front the phone, and it will toggle on and off the details of the credit card. But let's see first the code and the demo, and then the code. So you can see I went on almost 1 minute and it's still there. Just one thing to know is that the browser, if the battery is lower than a specific percentage, can deny us from requesting the wake lock. That is the object that allows us to keep the screen on. So orientation. Here I have the credit card, my credit card details. We can identify a specific pattern. We can see we are listening to inclination on the beta event, so back, front to back. And I can say, okay, I go on till 160, and then we can see active true. So we set a specific flag to true when we reach an angle. And now, if this flag is true and we go back to another, we don't have the wake lock, we don't have to back to the specific angle, we can trigger a specific action. So down and back. And this is just another idea, how we can extend the possibilities and the features of our web application. Of course, I can do this simply with a toggle button, absolutely, but why don't try to innovate? Or again, the goal of this session is also try to spark some ideas, or maybe in your project say, oh, right, this could be cool, and I can do it. So hopefully you can get some hints for the next projects. How can we do that? So we listen to the device orientation event, and in this case, we focus on the beta event. We can define a range of degrees. In this case, the beta goes from minus 180 to 180. We can define an exclude range, so that we don't want that the user can also play kind of the contortionist and go back. We want only to consider a specific range. And then if, as we said, if we go, or if we reach a specific degree, we can set a flag to true. And then if we go back in a so-called active range, when the flag is true, means that the user did or achieved a specific movement that we wanted to achieve. And then this will, in the specific case of the demo, will trigger the hide or show details. This brings us to the next and last, or maybe not the last, demo. So a little bit of story for this. In my phone, unfortunately, I didn't have the timer for the selfie. Of course, I could have downloaded a native app that allows that, but why don't implement one if we can? Therefore, I start thinking, okay, thanks to the media API, is another web API that allows to use all the media devices, media inputs of the device and get them as a video stream. Therefore, we can then take a frame of the video, and with that we have our photo. However, I'm not a professional YouTuber or selfie maker. Sometimes I had some troubles with my thumb going in the proper direction. And then I thought, okay, why don't I combine my media API with the orientation API? Why don't I use a kind of gesture together with the media API to say, okay, I do this gesture, then I instruct the logic of my application to shutter or to do the timer 3-5 seconds and do the photo for me. It would be much more easier than having to find the shutter icon and click. So here, let's see, 1, 2, 3, and it did it. Now we have our image. It's not very visible, but there is another icon. With this icon, we can invoke another web API called Share API. What does this API do? Or the goal is that I click on it, and then I can pass a payload, or I can pass some information. Could be text, body, or URL, or a file, like in this case. And then a set of native apps on the target device are proposed, and the user can select one of them and choose to share it. So in this case, with a couple of clicks, I could go from my web app, thanks to the Share API, and I share it to WhatsApp. Could have been an email, or could be any other native app. It's interesting here to, okay, I cannot see myself, to just mention that in this case is a little bit more complex, the pattern, because we could take photos in a portrait mode, and then we listen to the beta events. But we can also use on the landscape mode, and then we should use the gamma, because we are rotating them. But what if the user does like that? Then we have also to detect if we are in landscape primary or landscape secondary, because then the range of the gamma is completely flipped. So we have also to do a little bit of more logic to detect this. However, in the repo, you have this code if you are interested to see and how I implement it. And if you find, most probably there will be, even a smarter way, please let me know. We have another 5-6 minutes. I would like to finish to show you how progressive web apps can benefit not only mobile devices or mobile context. We can also do great things also for desktop context. In this case, we can check another API, the file system API. I think many of you are already aware that every time we want to interact and save a local text file, every time we have to open the file picker with the content of the file, and then either save and overwrite the file or save it in a new location. And this every time we want to save a file content. However, thanks to the file system API, we can open a text file, here for example, and by doing this, we create a direct connection. We get a so-called file handle. That means that now edited at the Vox UK, if I change it and I save it, then the saves are persisted straight to that file. As you can see, no file picker opened. Now I go and I open it again, and the changes are there. But I'm working with a web application. It's not Word, it's not a desktop application. And still, it looks like, or it provides the idea of having to deal with Electron or a desktop application. That is a very nice introduction or very nice thing if we have to also to provide or to take into account the desktop users. If we already installed our progressive web app, we can, it's not here. We should be able to see it in the application. But here we can see there is an icon open with modern web, because I already installed it before, and it detects that if we access a URL that is within the scope of our service worker, the service worker will make that it opens as a PWA and not as a part of the browser. So it will, if the URL is within the scope of our application, it does not open Chrome, it will open as it would be a native app. So in this case, yes, open it. You can see, if I open the progressive app now, it looks like really a desktop application. I don't have anymore the address bar, and down in the taskbar, would be the same in Windows, I have the icon. Therefore, I could pin it to the taskbar, and from next moment on, I click on it, bam, it's opened. And exactly as it was on a mobile device. So this also brings me to say that indeed in the future, the future of PWAs is really bright. We can achieve many powerful things. And other things that are coming, for example, we can use web GPU. It's a very or relatively new API that allow us to leverage the computation power of the local GPU. Therefore, on a machine, we can use the local GPU to start running maybe LLM. So these, together with the PWAs, can, in the future, really provide a lot of fun, I would say. OK. Here is the link to the repo, where you have, as I say, the live demo, and you can see all the code, handle for the Twitter, and the link to my educative portal course. I will be here later on and also in the next 2 days. So if in the next days any question or anything you would like to ask, come on, please approach me and ask me. Are any questions so far? Yeah?
That's really cool.
Thank you.
When you did the local file system manipulation stuff, I started thinking that there's probably a bunch of new attack vectors new attack vectors opened up by using that kind of feature with the progressive web app. Is there any kind of best practices or testing, best practices in testing that goes around securing these kind of applications?
Well, these web APIs start already to be quite or not so permissive. For example, you as a user must select explicitly a file. You cannot do that programmatically. And by doing this, but you would do also with an input type file, you would, as a user, you give the read access to implicitly to that file. So in that case, it's a little bit secure per se, because many of the APIs we saw are not possible programmatically. They always need not only HTTPS, but also a user interaction. That means that for the wake lock, we have to click on the checkbox, or in the light sensor, for example, at the beginning, we have to provide the permission to read the light the first time. And in this case, the user must select a file for it. And then in my case, and this is a new thing that introduced, because the permission is persisted, if it would be the first time and you read a file, then you edit and you save, you will get a prompt saying, do you want to edit or to give edit permissions? And then you have to say yes. And then, of course, this permission is persisted locally, so that you don't open tomorrow and again every time you open a file, you have to say yes, allow it. So in that sense, the web API in any case lead already to this kind of security indeed.
Is that part of like the specification for those APIs, or is that decisions taken by like Chrome, Safari, Firefox, etc.?
Yeah, we didn't see, but you can see in the demos, the lower part you have a. Let's maybe. In the lower part, you have always a chart from a Kenai website, and gives you per browser what is the compatibility, if it's possible to use it or not. Thanks also to the Fugu team and so on, they try to spread and to make all these API as much as cross browser compatible as possible in order to be able to indeed to use more and more these capabilities across all browsers. Yeah, welcome.
Yeah, obviously different tools have their own different use cases. When would you use a native app versus a progressive web app? For what applications?
Most probably native app when we have a really resource consuming or a really demanding application, then in that case I would say yes, native app is definitely the solution to go. But that we have seen plenty of application, and there are some others that are really, really nice. Is up scope. Yeah, is a up scope. This is like a gallery of applications. All these applications are all PWA. So you can see, you can really achieve not trivial application by category and so on. Therefore, even though native apps are by far more powerful for CPU, RAM, and so on, users and capabilities, so we can really achieve great stuff even with PWAs. So, as I said at the beginning, the feature gap or the gap of capabilities got in the years always really, really narrower and narrower. So this is also another interesting website you can visit, Upscope.
Check that one out. Cheers.
Yeah, thank you. All right, then, if there are no other questions, I think we all deserve a tea or a beer. And thank you very much, everyone, for the attention. And I hope you enjoyed.